Jai Hind to all of you. I am Dr. Himani Garg, working as professor in Department of Electronics and Communication Engineering at Akgec Garg Engineering College, Ghaziabad. Today I am going to discuss about digital modulation schemes. As we all know, modulation is the foremost requirement for transmission of a signal over a longer distance. So without modulation, we can't think of sending a signal over longer distance. In modulation, two things are involved. One is the carrier signal, another is the message signal. Message is a low frequency signal and carrier is a high frequency signal. So the property of the carrier is varied according to the parameters of the message signal. Now these parameters can be amplitude, frequency or phase. So in this way we will be doing modulation. Now as explained here, modulation is defined as the process by which some characteristics of a carrier is varied in accordance with the modulating wave. So modulating wave here is the message signal that is used to change the parameters of the carrier. The message as a result of pulse digit modulation is termed as digital message. We have already discussed about different modulation scheme, pulse modulation schemes like pulse position modulation, pulse digital code modulation, pulse amplitude modulation. These are not digital modulation techniques because in these modulation schemes, these signals can't be transmitted. Why? Because they are in the lower frequency range. So whenever we have to transmit the signal over longer distance, then we will have to change it to the high frequency signal. That's why we will need digital modulation schemes. This digital message is still in the baseband range. Direct transmission of such message over long distance via high frequency channel is not possible because it is of a low frequency signal and the channel is of high frequency. So we can't think of sending this signal over high frequency channel. In digital communication, the modulating wave consists of binary data or an M-array encoded version of it and the carrier is sinusoidal wave. So this is the digital modulation in which we are having the carrier is the sinusoidal wave, but our message is in the form of digits, that is 1 and 0. So in this way we will be modulating the sinusoidal carrier so as to transmit our signal over a longer distance. Now if you categorize the digital modulation schemes, we are having coherent and non-coherent digital modulation techniques. Under coherent, one is binary. Binary means M is equal to 2, 0 or 1, M array, then hybrid. Now binary techniques include ASK, that is amplitude shift keying, FSK, frequency shift keying and PSK, phase shift keying. M array, now if you are rather than binary, if you are using 4 bits, another number of bits, then we can have M array ASK, M array FSK, M array PSK, QPSK, quadrature phase shift keying. Hybrid we can have so as to get the better results, so as to use the advantages of both the types of binary and M array signaling, or you can say ASK, FSK, all these techniques. We are having the hybrid digital techniques also like M array APSK, that means amplitude phase shift keying, quadrature, QM stands for quadrature amplitude modulation. Non-coherent, there can be coherent or non-coherent, the same things ASK, FSK, DPSK, M array SK, M array FSK, M array DPSK. For these we are having both coherent and non-coherent. All of us know the difference between coherent and non-coherent or synchronous, asynchronous. Both are synchronized. In the case of coherent, the transmitter and receiver are synchronized or coherent with each other. In non-coherent schemes, both are not in synchronous, they are asynchronous with each other. Now as in the case of analog message, the digital message needs to be translated to the higher frequency range. The technique for achieving the same are termed as digital modulation techniques. So the same definition has been repeated here so as to make you more clear about the digital modulation technique. Digital modulation techniques are based on the analog modulation techniques. In analog we are having amplitude, in digital we are having amplitude shift keying. In analog we are having frequency modulation, in digital we are having frequency shift keying. In analog phase modulation, phase shift keying in digital. The main difference between the analog and digital modulation process is the former involves message have infinite level, whereas the later involves message having finite levels. So when I am talking about infinite, that means we are talking about analog signal. The message is analog, so it has infinite levels. It has infinite levels. Number of infinite levels are there. But when I am talking about finite level signal, that means 1 or 0, 1 and 0, 1, 0. So it has having the two finite levels, 1 and 0. So the message signal in this case is digital. In this analog modulation, the message signal is analog, having infinite levels. Now, coming to the basic digital modulation techniques include ASK, that is amplitude shift keying, frequency shift keying, and phase shift keying. Amplitude shift keying is a type of amplitude modulation which represents the binary data in the form of variations in the amplitude of the signal. Why we are calling it as binary data? Because our message is in the form of digital bits 1 and 0, and for this we are converting our message signal in the form of carrier, that is an analog signal. Message is there or message is not there. Has a high frequency carrier. Any modulated signal has a high frequency carrier. This is a foremost requirement, that any carrier that should be a high frequency carrier. We also know that if we calculate the value of lambda, or we can say if we have to calculate the value of we have to calculate the value of the height of the antenna, then we can calculate that height of the antenna is inversely proportional to the wavelength. So higher the frequency, the lower the size of the antenna. So that's why we prefer that in modulation the frequency that is to be transmitted, that should be of very high value. Now, strength of the carrier signal is varied to represent binary 1 or 0. Both frequency and phase remains constant while amplitude changes. Now, if I am talking about carrier, if this is my carrier, if I am talking about my carrier, then what we are saying that in ASK, strength of the carrier is varied to represent binary 1 or 0. Both frequency, there will be no change in the frequency or phase, only the amplitude of the carrier signal will vary. One of the amplitude is 0. So you can see here, if this is our signal, then the modulated signal will look like this: A0 cos 2 pi FCT, where FC represents the frequency of the carrier, and another signal will be A1 cos 2 pi FCT. They both will be of the same frequency, but the difference here is in the amplitude. Now, the amplitude of the carrier is on the basis of message signal, and here the message signal is in the digital form. Either it is 1 or it is 0. 1 means if there is 1, then A1 will be there. If the binary input is 0, then A0 will be there. So there will be two amplitude levels. Now, in demodulation, only the presence or absence of sinusoidal in a given time interval needs to be determined. Now, if we are demodulating the amplitude shift keying message, then at the receiver end, either the signal will be present or it will be absent. For if the signal is present, that means 1 has been transmitted. If there is no signal, amplitude is A0, you can say, then there is 0 is being transmitted. So it is a very simple method. It is a very simple for transmission as well as reception. Now, what is the major disadvantage is that ASK is very susceptible to noise interference. As we know that most of the noise mostly affects the amplitude of a signal, and here in this amplitude shift keying, we are changing where modulation is affecting the amplitude of the message signal. That's a amplitude of the carrier signal. So that's why it is more susceptible to interference. Noise usually affects the amplitude, therefore ASK is the modulation technique most affected by noise. Application ASK is used to transmit digital data over optical fiber. Means for 1 there is light, for 0 there is no light. As I am again repeating, now you can see the same things in the pictorial view, in the diagrammatic view. This is our message signal. that is 1 0 in the digital form. This is the foremost requirement of digital modulation scheme, that our message is in the digital form having 1 and zeros. As you can clearly see here, the carrier is in analog form. The carrier is in analog form. Now after modulation, you can see here, this is the ASK modulated signal. For 1 there is carrier, for 0 there is no carrier. That means for 0 the modulated, here we can say we are having A1, this is the amplitude, and this is A0. So A0 amplitude is 0, A0 is 0, so that's why A0 cos 2 pi fct that we were transmitting. In earlier we were transmitting A0 cos 2 pi fct, A0 cos 2 pi fct. If A0 is 0, then ultimately this will be transmitted. For the other one, A1, there will be carrier. Now the ASK modulator block diagram comprises of carrier signal generator, the binary sequence from the message signal, and the band limited filter. Following is the block diagram. We can see the block diagram here. You can see here, this is the ASK modulator. You are having, I will be showing you number of modulators. This is one of the type of ASK modulator, one type of ASK modulator. Here we can see, this is your message, this is your message, digital message, that is 1 and 0 is there, and oscillator. The function of the oscillator is to generate high frequency carrier. Now if you multiply the message with the carrier, for message 1 you will multiplying it by carrier, then the carrier will be present. For 0 you will be multiplying it with carrier, then no signal will be there. For 1 you will be multiplying it with carrier and the carrier will be present. And in this way you can directly see from this diagram also, 1 0 1 0 1 0 1 1 0, this is the message that is being transmitted, and this is a high frequency carrier that is carrying our message signal. So 1 there is message, for 0 0, for 1 1 the message signal is here. So this is the amplitude shift keying, modulated amplitude shift keying. It is shifting from 1 to 0 depending upon the message signal. This is another way. Earlier this method included a oscillator and multiplication of the oscillator signal and the message signal. Now you can see this in another method. We are using a switch. This is unipolar bisequence sequence. This is our message and this is our carrier. Message means in the digital form 1 and 0, and here we are having switch. Now this switch is controlled by this message. For 1, this switch will be on. On means this signal can pass through where we will get the output. For 0, this this signal will be switch will be off, and the carrier, no carrier will be transmitted, and ultimately we will get 0. This is ASK output that will give the same equation. This is the same type of signal as this. For 1 there will be signal, for 0 there will be no signal, for 1 there will be signal. The carrier generator sends a continuous high frequency carrier, the binary sequence from the message signal. As I have already told you, the message signal, that is 1 0, the unipolar input to be either high or low. The high signal closes the switch allowing a carrier wave, hence the output will be carrier signal at high input. When there is low input, the switch opens allowing no voltage to appear, hence the output will be low. This is a very simple function that is being used, but the disadvantage here is the disadvantage we have already discussed, that the noise mainly affect the amplitude of the signal. That's why this is the major disadvantage of ASK modulation. The band limiting filter shapes the pulse depending upon the amplitude and phase characteristics of the band limiting filter or the pulse shaping filter. Filters are mostly required in the digital modulation schemes, because whatever waveform we will get at the receiver, that will not be a perfect square wave. So as to get the perfect digital signal of the square wave, we require a filter. Now when we come to the ASK demodulation, there are two types of ASK demodulation techniques: ASK, asynchronous, and synchronous. Demodulation or detection, synchronous demodulation or detection. Now, what is the difference between synchronous and asynchronous? The clock frequency and phase at the transmitter, when they matches with the clock frequency and phase at the receiver, it is known as synchronous method. Both the clock of the carrier, of the transmitter and the receiver, if they are synchronized with each other, then it is called synchronous. If the both are not synchronized with each other, then it is called asynchronous. Otherwise, it is known as asynchronous. Now, we will discuss about asynchronous ASK demodulation. Now, we have received which type of signal at the receiver? This is the modulated signal that has been received at the receiver. This is the modulated signal that has been received. From this signal, we have to ultimately demodulate this signal and have to receive 1 and 0. Our aim is to convert the modulated signal into demodulated digital message signal. So, the basic blocks for demodulation includes half wave rectifier, a low pass filter and a comparator. Following, you can see the block diagram. So, rectifier, as I have shown you earlier, this is the modulated ASK. You can see for 1 there is carrier, for 0 there is no carrier, for 1 there is carrier. So, the first thing for demodulation is we will rectify the signal. As we know that the how the our message signal was looking like, this was our message signal that is above 0 level. So, firstly from this message signal we will remove the rectify the lower part and we will get this type of signal after rectification. After rectification, this signal is there. This signal is passed through low pass filter because our message was a low frequency signal. So, it is passed through low pass filter and then it is given to the comparator. Comparator is given so that we were getting the actual shape of the message signal that was being transmitted. So, there may be that this is not totally, there may be rectangular or a square pulse. So, there will be some noise added in it. You can have a comparator that will compare the message signal with the another threshold and ultimately we will get a pure rectangular waveform. So, this is the purpose of comparator, to compare the level of the signal. If it is above this particular, if this is a threshold, if it is above this threshold level, then 1 will be there. If it is below the threshold, then 0 will be transmitted and ultimately we will get a pure square wave or the message signal that was a digital in nature. So, this is how the asynchronous demodulator works. The modulated ASK signal is given to the half wave rectifier which delivers a positive half output. The low pass filter suppresses the higher frequencies and gives an envelope detected output from which comparator delivers a digital output. Now, this is the another signal. So, in this way we are getting the synchronous detector, asynchronous detector. So, today we discussed about the basics of digital modulation schemes, how they are different from analog modulation schemes, and then we discussed about the types of digital modulation schemes, ASK, FSK, PSK, and in detail we discussed about ASK, amplitude modulation, ASK modulation and demodulation, and these are the references that we have followed. Thank you for listening to this. I will continue with the digital modulation schemes in my next lecture. Thank you for listening.